I'm guessing this will probably be people's favorite lesson of the whole semester because it is the last one, which is crazy. But we're kind of playing off of what we did last time. We graphed a linear inequality last time on the coordinate plane. Today we're graphing systems of linear inequalities. So it's the exact same thing we did last time, except instead of just one inequality, you're going to put two on the same graph. So let's remind ourselves, when we started talking about systems earlier this unit, we solved a system, which was just two equations. One of our methods of solving was by graphing. So let's kind of review that. This is good to review for our exam, which will happen very soon here. But when I solve two equations by graphing, I just graph both lines. So the first one I'll do in pink, the y-intercept is 1, and I would go up 1, right 2. I could go down 1, left 2. If it's just an equation, an equal sign, I don't have to think about shading or what kind of line it is. It's just a regular old line. The second equation, I'm going to do in purple here. This one has a y-intercept of 8. And you guys, you have to forgive me, but this graph is terrible for this y-intercept because it only goes up to like 6.5. So we're going to just roll with it. Make like one more little tick mark up here, bear with me, and we're going to call that 8. So we'll say this is 7, this is 8. So when I count my slope of negative 3 over 1, I'm going to go down 3, right 1, down 3, right 1, and right there I landed on the pink line. So I know that where the lines cross, that's my answer. So solution, when it's a linear equations, just equal sign, there's usually only one solution, unless it's one of your special cases. So right here, there's only one solution, and it's this ordered pair, which is 2, 2. That's the only x and y value that you can plug it into both equations, and it works in both. Okay, let's shift gears and talk about a system of linear inequalities. So this is the exact same numbers, and it's 1/2 x plus 1, negative 3x plus 8. All of that is the same, but the difference is instead of equal signs, making them equations, I see a greater than and then a less than or equal to. So these are inequalities. Everything else has stayed the same. So this is what we're focusing on today. I'm going to graph both of these. And remember, when you graph something, you're just showing someone a visual of where the solutions lie. So I'm going to show all the solutions. That word's kind of a key word there because there are way more than just one answer when it's an inequality. So we're going to point out where the solutions lie after we graph it, and then we'll name just one possible answer down here on the solution line. Notice this helpful tip right here. I would strongly suggest using a different colored pen for each line, or maybe like a pen and a pencil. Use something that's going to like differentiate the two because it's way easier to see where your answers lie if you do that. So I'm going to stick with pink and purple here. So the first line I'm going to graph in pink. Remember, when you're graphing an inequality, you plot the points like normal. So I'm going to start at 1, go up 1 over 2. All of this is the same as the review problem from up above. Oop, and I just got a little crazy. I need to remember. See how easy it is to like just automatically want to draw like a solid line? But remember, like I almost forgot, you need to remember two things when you're graphing an inequality. So if it has a greater than or a less than, you need to remember what kind of line it is. It's sometimes dashed, it's sometimes solid. If it has the solid line underneath the symbol, then it's solid on the graph. If it does not have that solid line, it's dashed. So I was almost quick to draw that line. This is actually a dashed line because it doesn't have the solid line underneath the sign. So I kind of saved myself here. That means that ordered pairs on this line do not satisfy that inequality. They do not make it true. You also have to think about where to shade. So you either shade above the line or below the line. The greater thans they shade above the line, So greater than or equal to, and the less thans shade below the line. So hopefully you can tell the difference. This is a greater than, so I know I shade above the line. And I'm going to do my shading really light. I mean, I'm using pen, so it's going to show up either way. But don't go crazy and like color it super dark if you can help it. And you'll see why in a second. The second line here, I'm going to do in purple. So really, you guys, if you got yesterday's lesson down, this should not be that bad because you're just doing 2 on the same graph. And I know that I'm going to have a problem because it's negative 3x plus 8. So again, bear with me. Just go 1 mark up, call that 8. Go down 3, right 1, down 3, right 1. This one would be a solid line because it's got that solid line underneath the sign. This is a less than. If you have trouble deciding, okay, well, the line's super steep. It kind of looks like right and left, not below and above. You want to shade the y-axis that's below the line. You want to shade the y-axis that's above the line. So that's kind of like another thing you can play into the sentence when you decide where to shade. So go to the y-intercept. This is a less than. I want to shade the y-axis below the line. So that would be down here. So it'd be this way. Everything this side of the line. Okay, there's an important note to make about the shading. The solutions, so we know that there's like way more solutions to inequalities than equations. The solutions to this system of inequalities is where the shadings overlap. Okay, this section should be shaded darker so that way it stands out. So you need to identify, and here's where if you use 2 different colors, it might be easier to see. But for me, I'm just going to say, where do my pink and my purple shadings overlap? That section is where I want to shade darkest. So I can tell that it's like this upper left corner. So in highlighter, I'm going to go in and shade that region. And you don't have to use a highlighter. You could just shade it darker with your pen or pencil. But it should be super obvious to me, like when I grade your exam and whatnot, that's where the shadings overlap. You should shade that darkest. Because when I go to name a solution, that's where I'm going to look. I can pick any ordered pair in that shaded region, and it should satisfy the inequalities. So literally does not matter. Maybe I'll just pick that point right there. So that's the ordered pair, 1, 2, 3, negative 3, 2. And I'm going to write, there's tons of options. Anything in the shaded region. Negative 3, 2 will work. Okay, so that's essentially all we're doing. I'm going to do 3 of these for you, and then you're going to try 1 on your own, and then that is it. You might cry of happiness that it's over. Just kidding. All right, so we're going to graph the system of inequalities and to show the solutions, and then we're going to name just 1 solution. So first line, I'm going to do that one in pink. I would strongly recommend doing 2 different colors. Y-intercept's negative 5, go up 2, right 1. Okay, you got to think about what kind of line is it and where do you shade. I do not see the solid line underneath this sign, so this is a dashed line. And where do I shade? Well, this is a greater than, so if I go to the y-intercept, I want the y-axis above the line, this way. Okay, you shade above, all that. Remember, and I'm going to use purple for this second line, remember that if it's not in mx plus b, you need to solve for y, so that way you can graph it. So I would subtract the 3x on this second line, and then I would divide by 4, and I would have y is less than negative 3/4 x plus 3. So that's what I want to graph in purple here. That has a y-intercept of 3, and I would count my slope by going down 3, right 4. This one's also a dashed line because it doesn't have the or equal to solid line underneath. And I want to shade this one below because that's a less than. So again, if you have trouble seeing, you can go to the y-intercept and you're looking for the y-axis that's below the line. So down here, all the numbers that are smaller than that. And I want to shade extra dark where my pink and purple shadings overlap, which is this section. So any ordered pair in that region would work as a solution. So I'm just going to say 0, 0. Easy to pick out. Note that any of the ordered pairs on either line would not be solutions because both lines are dashed. All right, example number 2. First line's in mx plus b, so I'm going to graph that pretty easily. Y-intercept's at 2, and the slope is negative 1 over 1. So that would go down 1, right 1. This one's a solid line because it's got the solid line underneath the sign. And it's a greater than, so I'm going to shade above the line. The second line, I'm going to have to solve that for y, so I'm going to subtract 2x. And then I divide by negative 4. Be really careful. Remember last time we were reminded of this. You have to flip the sign when you multiply or divide both sides by a negative. And I divided everything by negative 4, so I have to flip this from a less than to a greater than. The slope, let's see, it's negative 2 over negative 4. That would be positive 1/2. And that would be minus 1. Okay, so watch out for that because that's going to change where your shading is, which would change where all the solutions are. So make sure you flip the sign. The y-intercept's negative 1. That would go up 1, right 2. This one's a dashed line. And the shading, that's a greater than, so I'm going to shade above the line. And here's where the shadings overlap, this region right here. So let's pick an ordered pair. Let's see, maybe this one right here. That is 2, 3. Ordered pairs on this solid line would have worked, but on the dashed line would not work. Okay, so be careful. All right, I'm going to do number 3, and then you guys are going to try 4. So sometimes you might get ones that we'll call them special, but we'll say they're just a little bit different than the others, and 3 and 4 are kind of like that. So number 3, first line's good to go. I'm going to go up 5, and then down 4, right 1. That's a solid line. This line's pretty slanted here, so be careful with your shading. You shade above. So again, come to the y-intercept, and you want the y-intercept that's, or the y-axis that's above this line, or greater than this line. So I want all these y values to be included in my shading. Therefore, I'm going to shade this way. Remember that if that was really hard to tell for you, you can always test an ordered pair. So let me remind you how to do that. 0, 0 is the easiest point to test. If you want to test 0, 0 on this one, here's what you would do. Let's see, I just plug in 0 for x and y. 0 times negative 4 is 0. Okay, so I'd be looking at this. Is 0 greater than or equal to 5? No, 0 is not bigger than 5. That did not work. So I want to shade on the other side of the line from where 0, 0 is. You would not want to shade this way because that's where 0, 0 is. You would shade the other way. So if shading is hard to tell, test a point for you. Okay? The second line I'm going to do in purple. I need to get y by itself, so I've got to get rid of that 2. So I'm going to divide everything by 2. I do not need to flip the sign because I'm dividing by positive 2. So it's going to be y is less than negative 4x minus 2. So that line's got a y-intercept of negative 2, and my slope would be down 4, right 1. Okay, this one's a dashed line because I do not have that solid line underneath this sign. And it's a less than, so I'm going to shade below the line. So again, if you go to the y-intercept, you want that y-axis that's lower than the line, or numbers smaller than where your y-intercept is. So I want all these to be shaded. So I'm going to go this way. Okay, this is a special case, and here's why. If I notice anything about the lines, well, they're parallel. They have the same slope, -4. And I notice the shadings do not overlap. This line shaded this way, this line shaded this way. That means that there's no solution, because I told you guys that where the shadings overlap, that's where the solutions lie. So if the shadings never crossed, there is no answer. No solution because the shadings never overlap. Okay, so sometimes if the lines are parallel, this can happen. You guys are going to try number 4, but I do want to point out one thing before I end this. I can look at these two lines right here, and I can tell right off the bat that they're parallel. And I can tell that because they have the same slope, -1/2. Do not automatically think that just because they're parallel, there's no solution. That's not always the case. And number 4 is going to show you that. Number 4, yeah, they're parallel, but there actually are solutions. So hopefully when you graph this, you will come up with some sort of answer. All right, that's it.